Hey, how are you? Yes, we do. I don't know what happened to the people, but we're supposed to have lab. Let me get my mask. For some reason, there's feedback coming in from the video. I don't know how to stop it. I guess what we'll do is try and stop this here. There, maybe that'll stop the feedback. No, it's not stopping it. If I do this, will that stop it? No. Let's stop the feedback. Just a minute. Gotta stop the feedback here. Maybe if I mute the audio, it'll stop. Sorry, what was the question? It's still feeding back. Why is it doing this? Morning. Morning. Sorry, could you ask it again? I couldn't hear you. How many labs? Yes. I don't know.
One lab was due. This lab
How many are due or how many more?
I think how many were due?
How many were due? I think there's one due today.
Yeah, one due tonight.
Tonight. And there were two others that were
Lab
due.
2, yeah. The
I
one
think
with
we're on
the
lab number 3.
Yeah,
yes, the one with the LEDs was due. And the deadline's off. The deadline's up.
Good. Yeah, I think we had lab number 3 is due today. And if we it's still at Echo.
No, 2.
Oh, due tomorrow at midnight.
No, it's 2 tonight.
Oh, okay.
Can't seem to stop the echo.
Is it Thursday?
The echo?
Yeah, from this thing.
Um,
Maybe if I put it somewhere.
if you mute your device, can you?
It is muted. Here, you show me. All right, so welcome to another exciting digital design lab. We've got an interesting lab here for today. What I did was, I still hear my voice coming out of that thing, and I got mute on it. So, I don't know, it's recording, so don't stop it. What I've done here is I've laid out 7 or so servos in the back, behind, well, right in front of the Elvis boards. And the servos are a little bit smaller than this one. This is a big one because I've got a little project in mind. And what I do, in order to improve the resolution of our ultrasonic sensors, is well, I guess I can put this over here. I put a little parabolic dish on top of the servo, like that. And then what I do is I hook up, this is a battery-operated device now, my little Arduino, and you can see it's scanning. I'll show that to the camera, and you folks can see it too. It's just scanning. So I've set the servo up to scan, just like a radar system. And what you want to do, once you get, things running properly, is you'll probably want to add an ultrasonic sensor to the device. So what I did in the center was I put on a 2mm standoff, and then I put on my little ultrasonic sensor, also with 2mm standoffs, and I just screw it in. And I'll hold that up for the camera so you can see it there once I get this in properly screwed in. So there's the ultrasonic sensor, and you can kind of see it here. And now, with my little sensor attached, I can proceed to do a scan. And there it is with the scanning. And so that's the ultrasonic sensor with the parabolic dish attached and a little servo. So we've already done ultrasonic sensors, and today we'll do the servos, and hopefully at some point we're going to combine the two so that we can actually do a scan of our surroundings. So that's kind of an interesting thing. Now you could have done the same thing if you just mounted the sensor on top of an autonomous land vehicle and had the autonomous land vehicle sort of sweep around with its wheels. But this is a reasonably good way to go. And in case you're wondering, this is a common 9-volt battery on a small DC adapter. And this allows you to have a portable device so you don't actually have to plug it into the computer. Once you program these things, the program just starts because of the Harvard architecture inside of the Arduino. So we're storing programs separately from data. And that's why we're able to get these things to boot and start immediately. In fact, booting is probably a generous term. They just launch their programs right away. Your basic underlying design consists of a pulse width modulated input and a DC 5 volts and a DC ground. And so what I'll do here is I'll take my little camera and I'll point it at the board so people can see. Your servo has 3 wires, red, black, and orange, or something else. And then what you'll do is for the red, you're going to hook it up to plus 5 volts. For the black, you're going to hook it up to ground. And for orange, you're going to hook it up to 9 volts. as it turns out, that's all the wiring you're going to need to do. There are some 3-wire jumpers available in the back for you to hook these things up. And what I can do here is I can show you a quick demo.
Can't mute this.
With the computer screen. Let's see if I can adjust this so that it can be seen by the audience. I'm using my iPhone for the first time to do the recording. I think it'll work okay. So what I did was I put up a couple of videos that are built into the lab, so you can watch them at will. When you open up the lab, you'll see the videos. But they're coming in off my .java website. And if you go to courseware, microcontrollers, you will see that there is a video here for the servos. What I'll do is I'll make this just a little bit bigger so that people can see it from Zoom.
Really the nicest thing about these is that they are.
These servos that we're using can be driven directly by the Arduino. And in fact, you can have, there are little robot arms. I have one myself, which will enable you to use the servos. So let's take a look at this Tinkercad. And so this is a servo with just 3 connectors. Here it is going to pin 9. In this case, we've got a little green wire coming out, although I think it's orange from the servo. The jumper was green. And we just use red for 5 volts. It won't work on 3. And we use black for ground. And 9 is the pulse width modulation output. And this is a simulation that isn't 100%. It kind of stops and then starts again. I'm not quite sure why, but it does that in simulation, not in the real hardware. And then if you take a look at the code, you're going to stop the simulation, and then you can modify the code. You'll see it's the simplest thing. I just included the servo.h. I don't really need the software serial because I'm not outputting anything on serial.begin. So you can delete that unless you want to include some sort of output to the console. There is a position sensor value. I'm not using that either. If you want to, you can build something that actually inputs from the rheostat of the potentiometer. This is servo 9 because we're attaching it to pin 9. That's PWM output 9. I'm not going to use the analog input on this particular example because this is the simplest first example, so you can delete that and the serial part. The serial that begin, I'm not going to use that either because I'm not outputting anything, at least not to the console. And then I just wrote a little for loop in here, and I just keep writing the position out with a delay of 15 milliseconds. And finally, I go to the beginning and sweep all the way back. That takes a while, so I delay for 1.5 milliseconds. I'm sorry, 1.5 seconds, 1500 milliseconds. And that's it. And that's it. That's the software. And it's really simple, actually. And we already talked a little bit about pulse width modulation and servos in class, so it's part of the lecture. And everybody here should have a servo at this point. Is that right? You'll get yourself a servo? It's right in front of the Elvis boards. Oh, and I got another video for you. Here's one. It's servos using Tinkercad. This one's a little bit more advanced.
The only reason you use one of these sheets is if you have why you no point.
So this is a Another example. In this example, we've got a little potentiometer, and the potentiometer is being used as a voltage divider. We've got an analog input, so this is cool because you've got an input and an output. And what we'll do is we'll drag the potentiometer around once we got the simulator running, and then this servo will track that potentiometer. So that's kind of cool. And that might be good if you were going to build like a rotor antenna and have the antenna point in a specific direction and you wanted to fine tune the angle at which it was pointing. So that's kind of a nice way to go. And now we've got a serial output. So we're going to use the software serial over in here. In our setup, we set up serial begin to 9600 baud, and now we can output the position value of the sensor and the position value of the servo. And you can see how the sensor is mapped between 0 and 180 degrees, whereas the servo is going from 0 to 180 degrees, whereas the sensor goes from 0 to 1023. And we can print that stuff out because we can. The new thing is this map. The map will take the sensor value, which goes from 0 to 123, and map it to numbers 0 to 180. This works for integers only. So this mapping is convenient when you have sensors that have different range than output devices. You could have done this easily in a piece of code, but it's convenient to have a nice little map function there. And that's the lab. And if you want to do this in simulation, because you don't have hardware, that's okay. You can do it with Tinkercad. And then just paste in your image and the code, all of the code, complete code, please. And then put it into a Word document, and you can use that as your submission. Or if you've got things working here in the lab, take a picture of what you have working, put the picture into your Word document along with the code. So we can do it either way. And that will help you to get a little hands-on experience with the servos. Now, did everybody get a servo? Yeah. Good. Good. So I expect to see some working servos here. And I think that it shouldn't be too difficult for you to set that up and get it working. Now, I remember Chris saying something like, you don't have to have the shield that I've got. This is a little bit of an extra, which allows you to plug in multiple servos. And then you don't have to have a separate wire going to ground and to power. And what you do when you plug this in, and I don't know if you can, if I can show this to the folks over here. I got this little sensor shield, they call it. So the sensor shield essentially allows you to have multiple servos and multiple inputs, and it makes it kind of convenient to wire things up. And I've got a few of those in the back as well if you want to try and use them. And what you do if you want pin 9 to work is you find the 9 on the silk screen where I've plugged in over in here, and then you plug in your jumper, and that'll simplify the wiring. That's particularly good if you're trying to do a robot arm with like 9 degrees of freedom or something. You're going to have like 9 different servos. You want to plug them into something convenient, or else it's going to be a rat's nest. So this will help you to organize the wiring. But for just one servo, I think Chris is correct. You don't really need a lot of these things. It's pulse width modulated. So that's what we got for today. If I can, I think I can bring up a live version of Tinkercad. Let's see if that'll work.
So like one simple way to make it number of different same with any part you don't know how to wire. Just look up the part, you know, like you should, there's no reason you would know how to wire it until you look it up and it'll say. But it's gonna be ground in this case. Yeah. Maybe one of these just to lengthen that.
All right, so now he says I have to check my device before I can log in. Darn it. How do I do that?
And then the other one's the signal, which can go into any of your digital pins.
You won't let me do it.
I can't log in because of a two-step verification on. Oh, did you have to?
I have the server plugged in.
Yeah.
Yeah, so you sort of well, you could do another pin, but like you just 5 volts is good. But you just plug it in.
Oh.
Yeah, like the signal wire can go into anywhere. So that orange wire you can plug into anything on this side. Yeah, any of the 13 ones. And then the other ones are 5 volts and ground.
All right, so this is not working.
So, yeah, so like if you were just to look up like
437397.
you would get servo
See if that works.
wires the
437.
same color as the one that you're wiring. That's not an Arduino. So that example here.
There's 1 and 9 with ground and 1
It's the same color. So you've got brown and brown, red 5 volts. He's using D3, but keep in mind that could be whatever. Technically, it could be an enormous thing.
All right, so here's my little Tinkercad system, and it's live. So now we don't need to watch videos anymore. Let's start the simulation and see if it works properly. Actually, it works much better here than on my Mac, so it's obviously an implementation issue. Here we are going for a full 180 degrees. Let's stop the simulation, take a look at the code, and we could probably make that larger, huh? How would we do that? I guess it can't be done.
You have to float over this, like a boundary, and like slide it over. So.
Like this?
Yeah.
But the text is the same size.
Not sure that's
How do you increase the font size?
not sure.
Yeah, I don't know either. It's a mystery.
So,
Yeah, so like over here,
like here's what you want to do. So like there, you're starting simple, like search simple, right? Like you don't need to like finish with like you don't need to start with something that like does the exact turning you want. You want to start by moving the servo, right? That's your initial goal.
so here's the
Just to
code
move the servo,
for you
not
guys to
like
take a look
do
at in
anything.
case you need it. And I don't think I need the
So
software
like
servo
just
over
like
here.
servo dot attach and yeah, so you gotta call up top, you gotta name your
So that
servo.
works fine.
You have the servo library download.
So all you have to do is do the include servo.h, and you should be all set.
Look up servo. I think it's included in the download, but
No, I just want you to output to the servo. Get the servo to turn.
yeah.
That's it. That's the
Yeah,
lab.
so that's installed. It's installed with.
Just get the servo to turn.
So up top you do your pound include caret servo.h, capitalized like less than symbol. Yeah, just one. And then servo.h, but capitalize that as this library name. Yeah, so those are going to operate identically in every single way, shape, and form as far as your Arduino code is concerned. Now, maybe as servos get bigger, they use more voltage or something. But these are all 5-volt servos, and like even though this one's bigger than that one, except for
Should we
maybe
submit
something
both parts, like both coding, like both parts of the code, like for part 1 and part 2 in the same Word document?
What's part 2?
Part 2, we have to rotate it 90 degrees at full speed, clockwise, and then counterclockwise full
Really?
speed. Yeah, it's on the PowerPoint.
So you've
It's
got
on the PowerPoint, so it's not in
you've
the-
got to
in
name
the
your servo,
Word
right? So you
assignment.
got to spell the servo.h library that you have first.
I saw it was on your Vimeo too.
Well, let's take a look.
So you're gonna go capital S servo, so, and so what this really gets back to, so what you're doing here is something that you'll learn more about later, but like this is like class-based programming, so like you're calling something a class servo, you're saying, I'm gonna create an object of class servo, and now you can name it, so you can say servo 1, my servo, whatever you want. Oh, keep it lowercase generally, because then it's going to want to call the servo library every time you type it. And so then you say servo 1 dot attach in your setup.
I don't know. You might have like a note. Oh, and it actually needs like wire.
Yeah, parentheses, and then the pin that is the control for your servo.
That would be yellow.
Here's one
Yes.
number.
And like maybe if it's like yellow.
Servos.
Yes, it's going to be yellow.
That's the number 8, and then
It
8
says-
comma what? 8.
Just that, yeah, close parentheses. And now your servo is finished. So you don't need to do pin mode or anything with this library. That library is going to do.
Okay.
So this part 1, servo 1 dot
Yeah,
attach.
there's no part 2.
It's going to decide what it needs to decide about that, right? You
This
don't need to
part
say pin mode, the output, or anything.
So I don't know if people are understanding the assignment.
So how do I?
You don't have to do a part 2 on this. This is a part 1 thing. Get your servo to work. I know in the PowerPoints, it says something or other about a part 2. And I think that's okay. You need to do it if you want, but the only thing I'm requiring is
Yeah,
get
so
your
like,
servo
so
to
like,
work.
the other thing
That's
that
it.
some people will do in the setup that you don't need to start by doing is to like write a certain position, like their start position, right? So like you might say like,
So
right
in
in
the
position,
setup.
No, I
yeah.
have
so
an
you
example
could
up here.
say,
I'll show you how it
servo
works.
1,
You can use my example. Okay.
and
There it is. Okay.
he's doing, you're using yours, okay, so then you just do dot right and give it an angle, maybe 9 or something if you want.
Right, that's it. That's all you need.
Yeah.
The numbers are going from 0 to 180 in
Yeah,
degrees.
semicolon,
So
then
it's
if you want,
degrees,
like you
not
could upload
radians.
that, and you should move.
All you
this
need is a
over.
for loop and a servo dot right with a small delay and you're there.
Right now, and you should know that.
At the end, if you want to, go
Right.
back to the beginning.
Because they should write 90 degrees.
You write 0 because it takes a while to go back to 0.
Oh, yeah, no.
So throw in a delay of 2 pads. 1500, whatever works.
Oh, hold on. Let me see.
Oh, semicolon after servo. It's making your word setup not work. It's just a weird error. After servo 1, not there. That's it. 1 below it. Yeah, the one there. I think that, yeah, sometimes you get the errors. I don't think it actually got your upload message.
So here's a classic problem. If you try to combine the servo with the ultrasonic sensor, you might find the sensor is using the same pins as the servo, or the LEDs are using the same pins as the servo. So you've got to be careful
That's not
about that. Here, in this case, the servo and the ultrasonic sensors just happen to be using different pins.
Yeah,
So
maybe
pin
something
6
else
and
will
7 are
confirm.
used for the ultrasonic sensor. So that should be okay.
Insert button. So we may need to check our connections here. Yeah, so that should write something. So
Red.
Yeah, right there.
that's going
So
to
we
white.
get this back up.
Wait, no, red's going to red. which you have going to 5 volts up here.
Yeah, red goes to 5 volts, black
And
to,
then black, you have going to blue. Blue, you have black on your signal. Oh, wait. So you have, yeah, and white also going to signal line. So you would either need to set that low or bring that over to a ground pin. Yeah, so now that should hopefully work.
power, ground, and then your pulse width modulation.
Yeah, so it moved. So we know it's connected and moving. So that must be its full rotation. So now, you know,
My thing is uploading, but so you think, yeah,
You're uploading again?
Oh, something wrong with the computers, I guess.
I don't think, I don't know, Chris, did you have any issues with uploading from your computer?
Compile it and upload.
How many volts is an HS?
program you online.
They might be wired because it's really
Probably not. I find that most of the situations where I get sad because I don't think it's something that I did, I'm usually wrong with the wire that's going on, whatever I'm doing. And it ends up just being like, I'm like, switch wires and stuff. I'm not an answer to that. I'm not a big fan of that.
Yeah.
I just did
And then
that
the
for
board.
I don't know. It's not what I'm supposed to program.
Hey.
Were you able to get the sensor shield though? That should be in
Yeah.
And you have to have orientation. To make sure ground. I'm gonna guess ground is the ground. Black. Oh, I see. Let me see how I do it. This color coding is just bizarre. You see, I have red,
There, but it's not
black,
black.
and then yellow.
Brown is ground.
Brown is ground.
Brown is ground. Red is signal.
Yeah, see, you see the word says G, D, and S.
Red is power.
Down to the ninth row. That should be.
In your case, sir.
I've got in my glasses to see if this is working.
I'm not sure. Did I put the shield on it?
What is it?
That's the way to do that.
Oh, yeah, no, you don't need that. You don't need that. That's, if you're gonna do the serial monitor, all you gotta do is do your serial dot begin and then say the baud rate, setup. You should maybe, like, once you get the circle running, like, it's a good exercise to maybe do that and then down here, like, have it report it, but you don't need to include library for that, not included in the IDE. This copy work, we
Wait a
need to
minute,
uninstall and reinstall these.
What do you have here?
There you go, you got some movement. So like now you can spruce it up with fancy stuff. You know, you could do a serial dot begin in your setup, and then you could report the position it's in, or like in here, you know,
Wait,
or something like that.
Serial that report.
Well, so first off, if you're going to be reporting position, you should change it so that instead of doing just full rotation, you're moving steps, because then you can report back where you move to, right? Instead of, otherwise you won't be able to in real time report your position. So like he did in Portable, do like a step thing where it steps like 1 degree or 2 degrees. So see the for loop you guys up there, like for in position equals 0, semicolon position less than or equal to 180, position plus plus, and then you can do servo dot right position, and it'll just step through every degree of position, right?
That's right.
Does that make sense?
Yeah.
And you can delay like 15 or something.
It's like the port on the other one. So
And then once you do that, you can add in a serial monitor. And when you do that delay 15, you can say, okay, well, spit out position, which would be the current position in degrees for the serial monitor, which I can show you how to do too.
So the servos are fine.
So like, and similar, you remember how we were writing microseconds to the sensor, like really when you tell this a number of degrees, this library is converting that to microseconds, right? Because this similarly is working on a pulse, right? And the number of microseconds of length that that pulse is going to decide how far. So when you get into really exact stuff and you maybe want to move less than a degree, right? Like, or if you were moving gears and 1 degree, when you're using a bunch of gears, could be way more out here, right? You could have more effect. And so sometimes you want to be way more exact, so you can actually say servo dot right microseconds. And each degree value is associated with the number of microseconds pulse, which is kind of crazy. But that's all wrapped up by this library. You can just give it a degree value. But you could say, so yeah, you not no dot there. And capitalize the M. Right, micro, I think it's full right microseconds. Yep, and then you can say, like, so it usually starts around like 800 or 900 and goes to like 2200. So say like, let's say 1200.
I thought it was milliseconds.
No.
For a servo, it's microseconds.
It works, so.
And for bipolar motors, they use microseconds. So I think because they're tiny pulses, right? And it just gives you that accuracy.
How do you tell it to run certain microseconds backwards?
So like it's always absolute, right? So like servo's position is absolute, like it knows where its position is relative to its, right? So it knows it's at 90 degrees or whatever. So you don't tell it to go 10 degrees back. You say go to 80 degrees. Right. And you could do a calculation to tell you that to make that simple, right, or whatever. But in terms of what this is hearing, it's not hearing go back 10 degrees. It's seeing go to 80 degrees.
Yeah, I think it might just
So when you have a range of microseconds that's like say 800 to 2000 or whatever, and that can change on different servos, that's analogous to saying I have a range of 0 to 180 degrees. It's almost like if you map those values across 0 to 180 degrees, like it's almost exactly the same. That's how like it's doing it when you tell it to write an angle. Is it's associating that angle with one of those values, and it's basically.
Gotcha. But like, you can't tell it to go backwards based off. Like, you can't tell it to go.
Well, so you know, that was a value. So if you had like, that's where you could create it. So right. So if you're writing a value, so say that's like just a val, then you could be looping and say val minus 10 or something, right? Like, and then you can write val, right? So yeah, you just got to get a little bit creative with the way that you go about doing that, and that can make coding for these like seem confusing sometimes, but it's not. You just got to be creative. Like it's pretty simple, just creative. Like,
Thank you.
hey, so you're moving around. Oh, that's a continuous rotation servo. Oh no, is it? Yeah, it is. Nice.
I know Jamie got some of those. Let's see it. Oh, wow, I love that.
Yeah, that's nice, right?
That's really cool. I'm going to show this to the class here. We never got the echo to stop, did we?
Well, it turns out you can't turn off the volume on Zoom on Apple device.
So here's You cannot turn up the volume.
Yeah, they don't let you turn it all the way off.
So there it is, at 100 and, what is this, a 360 degree servo.
Yeah,
That's cool.
So.
It is?
Sweet.
Maybe 270.
I love it. It looks like you can just keep going with it.
Yeah, I think you could go.
Yeah, why don't you just
Take off the left.
take off the right zero,
And then take out the delay.
take off the delay, and then increase 180 to like 1800 and see if it'll make 10 spins.
Okay.
Just add a zero on the end.
Is that a zero here?
Yeah.
So if you write
Now
per
upload.
second 3,000, it's not going to go all the way there. It's going to.
Here it goes. So here it is, just spinning.
Move and then.
That is cool. Gotta love that.
So what do I do now?
You want to take a picture of what you have and upload the code, and you're there. Thank you.
He's trying to go further in this time. It only goes that far. That's about 180. All right, so yeah, so your for loop. It might be above the limit of library. Next, just try putting a for loop where you're looping the loop through all the increment through all the positions. All right, so you're working. So
That's the math.
yeah, you got the for loop. That's sweet. So now,
Who goes around 360? That's it.
now why don't we try reporting the position? No, the position of the servo itself, right? So let's have the servo. So right here, you're telling the servo what position to go in as it goes around the circle, right? So as you tell the servo what position to go in, you could also tell yourself what position the Arduino is telling the servo to go in, right? And I'll show you. So in the setup, say serial.begin, capital S, in the setup position. Right after the servo got attached.
Oh, look at that, it worked. With the cable.
Was it really?
Yep.
Oh, that's very
Very.
Uh-huh.
Alright, I'm
So serial dot.
Oh no, the shield also needs a 9-volt input.
No, it doesn't.
It usually has a 9-volt connector where you that's the little battery thing or
Yeah. 9600. You remember talking about baud rate? That's the baud rate for your serial monitor. Where you're going to see that, yeah. Well, so it can be a different number, but there's only certain numbers that can be. You can see, there are other values you can set it to, and I'll show you where you can see those in a second. So now let's say, say serial dot print ln, so print line, parentheses. And then just say POS. And now re-upload that code. And now go to Tools, Serial Monitor, and it's spitting you out the position as it's there. Right? And so if you wanted, you could add like serial.print position equals before that or something, spruce it up or whatever, so that it's giving you a readable message. Or, you know, so that's one way to report what's happening back to you. Yeah, so then that's just gonna say position, so you're gonna want another serial.print. So make that just a serial.print. No line, because then it won't go to the new line, right? It'll stay on that line. Now do a serial.print line. And that one will just be the position. Yeah, exactly.
I could have done here.
Yes. Yes, but and then you make it a printout line.
John, you also need a whole other here.
That's not part of
What's
the lab.
that 080? That's 80 in audio.
Oh.
Oh, that's just like a big number.
Oh, that's
Yeah, you can see my solution is, I want to go parallel. I don't know if you can 3D print a parallel fish, but it's hard to
Well, the problem is I don't think the dish would do as well reverberated the sound if it was made of plastic. Is it? It's not shiny. I'm not looking at aluminum sheeting on Yeah.
Oh, this coat part.
If you just want to reflect sound, it should be a visible reflection. That's true.
So if you want to be recording conditions yourself, up your setup loop, so we can just use serial up again.
What did you say that? What did you say that the wire colors were? Black and brown.
So again. You're gonna get capitalized the accent. And then you're good for there. Like if you want, you can do a welcome message. Like I don't know, some people do that at the beginning of their code. But then in here, like so when you do your delay, you can say.
How many times it is.
Yeah, you could also do like say that it's starting rotation, whatever. I would do a print LN because then I'll go to the next line instead of going forever to the right.
Yeah.
Or yeah, you can do a /N2, that works. That's and so then down here, like where you're doing one of your delays, you can say your serial.print position.
I didn't compile mine.
Yeah, it's print line.
There we go.
So we can use the /N up there. Does it process as the exact? Oh, I always miss that too. I always switch those. Does it actually process identically? Oh yeah. If anything, you should try to make the attachment piece, like print the attachment piece and just find a bunch of like.
I think, yeah, I don't know, right. Well, I think
Printing like smooth parabolas is
Yeah,
like
that's a
it
lot of
would be rigid and stuff. It would have like edges and stuff like. Yeah. Was that just work when you plugged it in? Well, what were you doing on that or doing on that? So it involved putting 5-volt to that pin. I never uploaded anything. Alright, well, whatever it takes, just put 5-volt to this. It probably is just running whatever was on that Arduino, which could even be test coded before they send out. Control unit. So they think it's the console. You don't need that software serial thing, by the way. Like you don't need that serial monitor. I don't know why. That's the new trying to get it. You can use the serial monitor.
Yeah. It's just wired, right?
on that, or was it a different
Do
shoe?
anything. No. So let's see.
The stepper motor, you can use the stepper motor to work on.
Yeah, so let's go back to your, so that means it's probably just something little, which means that it's like, so you don't actually have a potentiometer on there. So without a potentiometer on there, that sensor value, the analog read, the math, none of those are doing anything because you're not actually using a potentiometer to change the value. Those are only relevant if you. Yeah, exactly. So like you're just gonna write like you're just gonna for loop and write like say like 0 to 1 equals.
Also, the scoop.
And servo dot write 0, servo dot write 1. And write that, right? And so like that, so that is very valid code. Don't think I'm telling you that's wrong, and it will work. But what that is based off of is having a potentiometer that you're rotating some to control the input.
Yeah, so you have two of them. And then
Yes, it would work with your potentiometer issues, but I would, at the moment, I would just not worry about the potentiometer mapping. I don't think he needs you to end it in with that.
Oh, right.
So this other position yourself with one from here.
Right.
So I would just start with just like a for loop that prints position from 0 to 180. You have your serial that prints there, which is great. So that'll report it. So you see that loop here, so things going for and position equals 0. So position equals or position is less than or equal to 180, position plus, and then just servo dot write position. Equal position
I
0.
can't believe that it's a 4.0 versus 5.0.
And then that's 180. So when you servo dot write, you're writing a different value.
If that's the issue, unless it might just be a
The servo dot H library is transport. Yeah, plus.
Yeah, this works.
Does?
And
Wow.
if you have, so I would get rid of the position you have up there since you're
So it's a
declaring it out
5.0
there.
servo board?
Or it could have been,
And
could be something wrong with the.
So you're just gonna send, let's see.
It's
Servo
that,
dot
that
write.
should like the issue, unless when you switch yours up. You change the show.
Starting at the.
Correct. And then.
Maybe I misunderstand how the 5.0
Right.
That works great.
And you were not taking out that potentiometer.
What's the difference? I mean, it has these.
Well, the difference is it's got.
These LEDs.
And that serial code that's telling you the position, you could put in your loop right before the delay. But then every time it updates the position, it'll also spit it out to the serial monitor, right? Oh, you got a lowercase right out here. It's probably gonna be just right there. So then, like that will spit out to you its position every time it rotates a degree. So upload this and servo 9. Sorry, servo 1.
It's just a convenient thing.
And the pins are 0 input and 13 output you need either of those.
Try it with the light. Try it with your Arduino and see if it works.
Yeah.
See if that shield works.
Yeah, these are analog inputs. These are,
Because you told the servo to attach to 9, so normally that's built-in mode, but this library does all that for you. You say, my servo's on pin 9, and it'll do the
yeah, he gives you a bunch of
digital writes and all that stuff.
And is that a servo? Censorship. That's a 4.0 version. There's a bunch of them.
Alright, so that's rotating, so now we'll check the serial monitor.
There's not much going on. Just a lot of.
And there you go, it's spitting out the answer. So just start it up. So if you wanted this to be faster, you would decrease that, correct. If you wanted it to be slower, you increase that. Another option is you can give it a step size. If you wanted it to be faster, right, that you have it set by like 3 or 5 degrees every loop instead of stepping by, you know, only 1 degree in your loop. That'd be adding like. So, well, so no, in your loop, maybe, so after or you just say it's
So that's that,
and you would
The
just
light is
add,
that shield might be
right? It's also gonna add